Molweni guys. Kusapho lwethu maqoma lo. Today, guys, I'm continuing a lesson with students sase college. That I'm tutoring. Today, you guys, we did a transformers, ne? So of which is yes, aqale sathetha get transformer at no load, ne? Then ke ngoku sathetha a transformer at load. Okay, dababonisa ke there and there uba okay, xa a transformer is at no load, xa a transformer is at load, yabo, and the influence type of load, the influence of type of a load, meaning okay, this load, is it inductive, capacitive, resistive, and how it impacts a current that is drawn by a secondary winding. But what I want to do in this session, which we did, guys, from a college, we must cover calculations whereby we ignored, remember, as calculations besizenza, we were ignoring internal voltage drops. Okay, so of which is, as calculation besizenza, they are not 100% accurate, because internal voltage drop into ekhoyo, and it's something that we cannot avoid. So the next calculation that we'll be doing will be based on internal voltage drop. Okay, of which is for us to know internal voltage drop. What we need to know what is the equivalent resistance of this transformer circuit. Okay, what is the equivalent reactance? Once I know the equivalent resistance and the equivalent reactance, okay, that means I can know the equivalent impedance. Okay, of which is, now once you know all of those set of values, you can determine if voltage drops kule transformer. But the problem with a transformer is one. There is only one challenge with the transformer. That challenge is that the primary circuit and the secondary circuit are electrically isolated from each other. If we can see, this primary circuit is electrically isolated from this secondary circuit. They are only connected to each other magnetically. Okay, they are only connected to each other magnetically. Okay, so to simplify calculations to determine internal voltage drops with transformer, what we use intoni into we use something that is called a method that is called method of referring. Okay, method of what? Referring. Okay, in this method, guys, there are two ways we can do this method. One we can refer at the secondary winding, okay, to the primary, the secondary windings, or we can refer the secondary winding to the primary winding. Okay, let us go to our circuit and do that. Okay guys, what do we mean if we are referring the secondary winding to the primary winding? And remember, guys, I have explained in class that this resistance imele resistance yale winding, and this resistance is there for resistance to represent this resistance is there to represent the resistance of this winding, and this reactance, which is inductive reactance, represent the inductive reactance of this winding, because a winding will have a resistance and a reactance. Because why does the winding also have a resistance? Is because a winding is made up of wire wound around a core, a magnetic core. Same thing, let me use red. This resistance imele the resistance of the secondary winding. Okay, then this reactance imele the reactance of the secondary winding. Okay, let's guess. Okay, let us go back. Okay, so guys, Z1 stands for the impedance of the primary winding overall. Then Z2 stands for the impedance of the secondary winding. Okay, fine. Okay, so the impedance, let me write it down. The impedance of the primary winding, Z1, is given by R1 plus JX1. Remember, Lord, this is the why am I saying plus? JX1. This is a resistive inductive circuit. You have a resistance, and an inductive reactance. Then Z2 is equals to R2 plus JX2. Okay, so we are sorted that side. Now let us refer the secondary winding to the primary winding. Okay, what we are actually doing, we are actually gonna remove the secondary resistance and the secondary impedance. Okay, I'm gonna wrap up again because I need space to represent this. Okay, I need just a bit nyana space now. Okay, here is the resistance of the secondary winding. Here is the reactance of the secondary winding. Okay, sorry, ngicela nje space. Okay, There we go. Okay. Okay. So once we refer ke ngoku guys, we put prime for the ones that we referred. For example, we're sorry. For example, we referred R2, so I'm gonna say R2 prime to show that I've referred the secondary resistance of the winding, of the secondary winding to the primary. Then DT X2 prime to show that I have referred the secondary reactance of the secondary winding to the primary winding. Okay, once we have referred, it means, guys, we can calculate now. We can actually calculate equivalent resistance, equivalent what reactance, equivalent impedance. Okay. Let's put this now. Okay, Nancy impedance, yes, secondary Z2. Okay. The formulas, let me write down the formulas that we use when we have referred the secondary winding to the primary winding. With equivalent resistance, we can calculate it as follows. E1, notice that I'm writing a subscript yam as E. Immediately when a subscript E, it means that is an equivalent. That signifies that this is an equivalent resistance. Okay, so equivalent resistance is equals to why are we calculating equivalent resistance and equivalent reactance and equivalent impedance? Is because we want to know the internal voltage drops of this transformer. Because internal voltage drops will determine the output voltage, the voltage that is appearing at the terminals, output terminals. Okay. E1 is equals to, which is the equivalent resistance referred to the primary, is equals to R1 plus R2 prime. It makes sense, guys, because basically what we effectively did we added the resistance secondary to the primary circuit, hence we add. Okay, then it's also equivalent to this formula, R1 plus R2, and this we derive, but what I can tell you is that this formula is derived using a turns ratio. Thina sifuna calculator. Sinale xesha lo derive. Okay, then equivalent reactance is given by X1 plus X2 prime. It makes sense because what we did, we took a reactance sazoyifaka phi kwi-primary circuit, which is equivalent you can guess, and you have guessed it right, guys, is equals to x2 open bracket 1 over 1 n1 over n2. Guys, this formula, this second formula, you can use it when you are given a turns ratio, guys. When you are given a turns ratio, it is easier to use this formula. Né? Then equivalent impedance here circuit yako is given by square root, okay, square root R equivalent resistance here yakho ne squared plus equivalent reactance yakho squared, and this is determined using the Pythagoras theorem. Okay, now let me show you the second scenario, or we can refer what the primary winding to the secondary winding. Senza ntoni, guys? You guessed it right. We are taking, let me put back as well, layer resistance na layer reactance back kwendawo yayo. Okay, let me put it kwendawo yayo. Okay, R2. I'm gonna need space, can have to wrap here. Okay, X2. Okay, what we are doing now, guys, we are taking a resistance here primary winding and reactance here primary winding. Sisa kwi secondary circuit, and kasise kwi secondary circuit, we no longer say R1, we say R1 prime to signify that we have referred this resistance to the secondary winding. Okay, then we no longer say X1, we say X1 prime to signify that we have referred this inductive reactance to the secondary winding. Okay, singalibali. Okay, sine load lapha na. Okay, you will see, guys, after ndinibhalele yonke lento. Me, when I teach something, is only because I want you to understand the calculation uba ihamba njani. Because if you're gonna calculate something that you don't even understand, yabo, ubala njengocrema ke ngoku, yabo. Okay, Z load ubala ngocrema, yabo, which is not right, guys, ne? Okay, iformula zethu ke ngoku zizoba njani? You've guessed it right. U R E2 This is why I'm writing RE2. It is to show that I've referred everything to the secondary winding. So RE2 is equals to R2 plus R1 prime. It makes sense because I took a resistance from this side, I added a resistance to this side. And it makes a logical sense. And then it is also equals to R2 plus R1. And notice when I write the tens ratio, I ndiqala ngobani go N2, then beno N1P ezantsi this time. If you look here, if you compare, yeah, okay, squared, then the benobani XE, which is the equivalent reactance, is equals to X2 plus X1 prime, which is equals to X2 plus X1 open brackets and 2 over N1. Yeah, and then impedance, you have guessed it right. Good. Impedance, you have guessed it right. E2, okay, is square root RE2 squared plus XE2 squared. Pythagoras, na? And the last formula and libelo ibhala, guys. Remember, if you have a resistance, you have equivalent reactance, and you can write the impedance in complex number form. Okay. So which means that OZ is you can also find it in complex number form. RE2 plus JXE2. This is in what? Complex number form. Okay, but the trick is with this one, answer I must convert it to what? To polar, and it in rectangular. I must convert it to polar form in order for me to know the actual value. If niyakhumbula with complex numbers, if you want to know the absolute value, ifumana in what? In polar form. Okay, then be some angle ethile na. Same goes ndilibele ibhala nala. ZE1 is equals to RE1 plus JXE1. And final answer yako you convert to polar to get polar form to get the actual equivalent what? Impedance. Okay, now what I'm gonna talk about next, I want to talk about important points, and I want to talk about important point. The important point is that, guys, let me write down. Important point is that if voltage across each winding is directly proportional to the number of turns. It makes a lot of sense. Remember a turns ratio. V1 over V2 is equals to N1, and basically guys, you know this from N1, from N2, N3. If you're winding in a turns as needs, you know that a voltage needs. It makes a lot of mathematical sense, because if V1 is high, that means N1 is high. If V2 is high, N2 is high. Or if V1 is low, N2 is what? It's low. Okay, those are the important points. Then moving on to the next section of this lesson, sizothetha ngento ekuthiwa yintoni? Ngento ekuthiwa yintoni? Yi-percentage. Percentage or per unit value. Okay. Per unit values. Okay. Percentage or per unit values. Okay. Banqale ngeligama lithi percentage. Abantu bayalazi lona, okay? We can write it off. Abantu bayayazi ba okay, percentage uminisha ntoni. Per unit value, guys, per unit value, if let's say bekubhalwa ne obanibani wakha u 23 out of 50, so kawufuna i-percentage ne kawufuna i-percentage, uzothatha la 23 umdivide ngobani? Ngo-53. 23 sorry, la 23 divide ngo-50, sorry, which is 0, bani, 46. Lena guys yi-per unit value. Yebo, yi-per unit value. Immediately ke ngondi times ngobani? Ngo-100 to see i-percentage. Then ke ngizofumana 46%. Lena yintoni? Percentage. Yabo? That means guys, if ndifuna uthatha ndifuna uthatha per unit value, ndimse PU di signifier per unit value, ndiyise ku-percentage. Ndizo i-per unit value ndimultiply ngobani? Ngo-100. Or if 100 if ndine-percentage ndifuna uyisa kwintoni? Kwi-per unit value again, ndizothatha i-percentage value ndiyidivide ngobani? Ngo-100, then ibe in per unit value. Okay, if ndifuna ubuyisela lo 46 back to per unit value, so okay, lo 46%, 46% divided by 100. Okay, ndibona okay ngu-0.46 ka eku-per unit value. Okay, basithethe ke ngoku ngale topic, why sine percentage or per unit value i-manufacturers ze-transformer xa zisinika i-resistance ye-windings, i-reactance ye-winding or i-impedance ye-winding, is either bazosinika in what? In percentage or per unit values. There is a reason for that, of which is I'm gonna go through those reasons. For example, in manufacture, xa isinika impedance, isinika percentage impedance, meaning it's equals to percentage resistance of the transformer, and JX, and sorry, okay, all of these values are in percentage form. Guys, never say unit upper. If a resistance, impedance, a reactance are in percentage or per unit form, you cannot say unit yazo ngubani zi-ohms. No, yabo, iso-ohms, yabo. If ufuna uzibeka kwe-ohms, mele uzisuse kwe-percentage value or uzisuse kwe-per unit value, calculate a value yazo exactly, yabo. So guys, this is not in ohms, okay? But let me go back. We can say is the in ohms is, yabo, because they are not a percentage or per unit. See, the ohms is going back, and then let us write down. So this is not in what? Not in ohms, as na unit. Okay, remember percentage per unit value are in a unit. Okay, this is just percentage. Okay, then let me use the blue color. Impedance something ayinikwa per unit. UPU ndinixelele mos uba usignifier that okay le nto ikwi per unit value, and okay, okay, sorry, per unit, and x. How do you go from the question is how do you go from this to that? The answer is we divide each by 100, and then ke ngoku izoba kwi per unit value. How do we go from per unit value to percentage values? We multiply each by 100. Okay, now mandithethe ngesizathu uba why we would be given impedance, resistance, reactance in percentage or per unit value is because there are two reasons, and those two reasons are basically good, valid reasons. And so the first reason is that, okay, if we have resistance, impedance, resistance, impedance, reactance in per unit value, as our values, they can apply to both. You can use them to either the primary or to either the secondary. How do I mean? Let me use pink now. For example, if ne resistance per unit value, ndingayisebenzisa le per unit value kwintoni? Sorry, resistance per unit value. Ndingayisebenzisa le resistance per unit value kwi-primary, V1, so yabona uba ndingafumana ntoni apha. Ndingakwazi ufumana I1, ndingakwazi ufumana i-equivalent resistance, ndingakwazi ufumana ntoni? I-supply voltage. Kwa the same per unit value, I can this per unit value, I can also use it in what? In the secondary winding. That is why manufacturers, they give us as values in per unit values or percentage values, because or per unit value ane or per unit values ndingabasebenza either primary or secondary. Is ngiyayisebenzisa either primary to get equivalent resistance primary, or to get equivalent resistance secondary. Yabo, the same per unit value isebenza macala. That is the main advantage of this. I2 RE2 over V2. That is the first reason why we use that. Okay, we use per unit value. Okay, moving on. Same thing that goes with same thing that goes with per unit value, reactance. Okay, I1 XE1 V1. Okay, and the same thing we can use it with secondary. Okay, without worrying, but okay, can I use it primary? No, you can use it in both windings. Okay, depending on which value you want, or which value the question wants you to calculate. Okay. Okay. Then I2 XE2. Then V2. Okay. Then same thing with impedance, per unit value impedance. Okay, I1 I1 ZE1 V1, and we can also use it when secondary. Okay, Z is equals to I2 XE2 V2. Okay, the second reason, this is the first reason why manufacturer give us in per unit value. The second reason is in order to calculate the voltage drop. Second reason, let me write that down. Second reason why manufacturers give us these values in percentage of in per unit value form. Okay, for example, if you know that if you are given in percentage form, you convert it to per unit value by dividing those percentage values by 100. Then you come ke ngokuzosebenza these formulas that I've just written down. Okay, the second reason is in order to calculate the voltage drop due to resistance and reactance, we normally need to know the value of current. Yabo? Okay, the second reason, xa sifuna calculator a voltage drop, for example, let's say ndifuna calculator a voltage drop due to resistance, and it's gonna be I1 RE1. This is a voltage drop due to resistance, due to internal resistance here transformer. Then internal voltage drop due to reactance transformer, ne? Let's say I've referred, this is for when I've referred to the primary. Okay, it's gonna be it's gonna be it's gonna be I1 XE1, ne? Or if I want to find a internal voltage drop due to a resistance transformer, but I'm referring to the secondary side. Yabo, I'm gonna say R is equals to I2 RE2. This is when I've referred to the secondary side. Or I'm gonna say Vx to find internal voltage drop here transformer due to the to the reactance, but ke ngoku referring to the secondary winding, I2 XE2. Okay, yabona apha guys, in order for me to balance voltage drop, mele ndazi intoni i-current, ane mele ndi-calculate i-current qala, of which is i-current we don't always we have to calculate it asiyazi, but i-advantage i-value zakho xa zikwi-percent xa zikwi-per unit value is that awudingi uba ubale intoni i-current. For example, if into zam zikwi per unit value, ndizothatha ngothi okay, i-voltage drop due to internal resistance referred to the primary side is basically equals to per unit resistance times i-supply voltage. Uqebile yabo, we don't need to know the current, yabo, we don't need to know the current to calculate i-voltage drop, yabo. Same goes for apha, ne? If ndizofuna ubala intoni internal voltage drop due to the internal reactance of the transformer referred to the primary, I'm simply gonna say okay, per unit, sorry, mele ndithe V1, but V1 is supply voltage. OV1 is the supply voltage per unit in per unit reactance times bani V1. I only just need to know what is my supply voltage. Same thing when we are referring to the secondary side. I'm gonna say I2RE2, which is equals to per unit value of intoni of a resistance times V2. Or even if you find that internal voltage drop due to a reactance ye transformer, so if minus so okay, per unit impedance and times ubani V2. Okay, now guys, we have actually discussed yonke into esizoyisebenzisa. We have actually gathered the tools that we're gonna need to do this calculation. Okay guys, now that we have gathered all the tools that we're gonna need to perform these calculations, and remember guys, we are still doing a single phase circuits, as Charlie 3-phase. These are still for single phase circuits. Okay, so I'm gonna read the question. The primary and secondary the primary and secondary resistances of a single phase, which is, that means a primary 2000 volts, secondary ku 400 volts. That means this transformer is basically a step down transformer. Okay, so i-primary resistance ku-0.8, i-secondary resistance ku-0.05 ohms respectively. Then but the corresponding leakage reactances, that means i-reactance ye-primary kubani ku-6, then i-reactance ye-secondary ku-0.2 ohms respectively. But it determine the following if the transformer draws a current of what? Of 28.5 amps. And if the transformer draws a current of 28.5 amps. Okay, I draw one. When was let me put this, because abantu, they will make a mistake when it comes to this. As a drawer, when we draw current, these are things that can make you make silly mistake. When you draw current, we mean that sithetha yintoni nge-primary current. Xa sithetha nge-delivered current, okay, sithetha yintoni nge-secondary current, I2. That is how we signify a primary current. Xa sithi draw, sithetha yintoni nge-primary current. Then xa sithi delivered, sithetha yintoni nge-secondary current. So let us write down our givens. So into esiyinikiweyo yintoni? A primary voltage, which is V1 is equals to 2000 volts. Then span of V2 is equals to 400 volts. Then sibe no resistance, sibe no R1, which is equals to R1 is 0.8 ohms. Then R2 is equals to 0.05 ohms. Then sibe ne reactance X1, which is 6 ohms. Sibe no X2, which is 0.2 ohms. Okay, fine. Bathi ke ngoku intoni enye esinayo, i-current I1, which is 28.5 amps. And bathi u-A uthini? Uthi let us determine the equivalent impedance referred to the primary. Basically, they are asking us to determine this. ZE1, this is referred to the primary. Okay, for us to find ZE1, there are two formulas we can use. ZE1 is equals to RE1 squared plus XE1 squared, or we can use the complex number formula, E1 plus J X E1. Okay, either one of them. But it means that let's calculate on RE1. RE1, remember, is equals to bani R1 plus R2 prime. That means we have prime means we have referred the secondary resistance to the primary winding. Okay, of which is as now R2 prime. So we have to use this formula, R1 plus obani R2, then N1 over N2. Guys, as now N1, as now N2. But to N1 over N2 turns ratio. Okay, turns ratio is V1 over V2 is equals to N1 over ubani N2. Doesn't matter again, nobe yaqwetha macala. If ndiyaqwetha, let's say ndithi N2 over N1, then ndithi V2 over V1 is still the same as saying N2 over bani N1. These are equally correct, these two. Still the same thing. If you are if you do the reciprocal on your left hand side and do the reciprocal on the right hand side, it's still the same equation. Yeah. Okay, so apha sothi R1 wethu ngubani? R1 wethu ngu-0 0.8 plus R2 wethu bani ngu-0.05, then bani 2000 over 400. Then equivalent resistance izoba ngubani? Equivalent resistance izoba ngu-2.05 ohms. Okay, sorry. Then we need to determine the equivalent impedance. Equivalent impedance izoba ngu equivalent reactance, izoba ngubani? X1 plus X2, then ibe ngubani? 2000 over N1 over N2, which is X1 bani? X1 was 6 plus 0.2 2000 over 400. Tefumano XE1 which is 11 ohms. Okay, now we can calculate Z. The terms we can use two formulas. We can use the Pythagoras formula, okay, which is square root square root E1 wethu ngubani? Bese mbalile ngu 2.05 squared plus that is RE1, then XE2, XE1 is 11 squared ndifumane yonke impedance yam, equivalent impedance, which is 11.189 ohms. Same goes if I'm using the complex formula, I'm gonna say, okay, ZE1 is equals to RE1, which is RE1, which is 2,05 plus J, then XE1, which is 11. Then I have to put this in polar to find the absolute value. Then the formula 11,189 79,443 degrees. Okay, we can ignore it degrees. Tina sifuna the actual value. Yabo. Okay. Then the next question said referred to the secondary. Okay. Because of time, I'm not gonna cover that. I'm gonna allow you guys to cover that. Because remember, I think the calculation is straightforward. Class ithetha ngentoni? Primary winding referred to the secondary side. Yayibona formula injani. Qha ke ngoku into etshintshayo is that uzothi V2 over V1. That means sothi kasi substitute apart. That means sothi 400 200, because I don't want to make a video be too long. Yabo. I have to shorten the video, yabo, and so that people, they can say, okay, you lendo, it's short and simple, yabo. Okay, then I'm gonna do UD, but let us calculate the percentage resistance of the transformer. Remember, a percentage resistance of the transformer, you can calculate it either when you are referring to the primary or either when you are referring to the secondary. It's your option. Yeah, but basically it's not an option in this case. Yeah, but if it's an option, yeah? Okay, let me say this. It's an option, but okay, let me write it down first. Remember, a percentage resistance, let's say in 70 a primary, yeah? Let's say in 70 primary percentage resistance, and let's say the formula ye per unit, yabo. Qha ke ngoku sizoyitimes ngo-100 because asifuni ibe per unit value, sifuna ibe percentage value. So I1 RE1 bendiyibhalile formula over V1, which is equals to singalibali times 100 because sifuna in what? In percentage value. And yabo, notice apha ndibhalanga PU to signify ndifuna intoni in percentage value. Okay, so izoba ngubani lo? Izoba IA1, which is the supply current, is equals to bani? Is equals to 28,5 28,5 now. Yes, 28,5. Sorry, 28,5. Then RE1 is besimbalile with previous question go 2,05, and then over supply voltage 2000 times 100. That means a percentage resistance yethu is basically 2,921%. Okay, and it must indicate we can also use referring to the secondary, but it's gonna be long. But for understanding, I want to show you. Okay. R percentage resistance xa sithetha ngokwe-secondary side sodinga bani? Sodinga u-I2, yabo? Yiloo nto xa sisebenzisa RE2. Yiloo nto xa sisebenzisa referring to the primary side, it is shorter, yabo? Apha ke ngomele siqale sibale ntoni? U-I2 singambala njani? Singathi 2000 anitsho sinikiwe i-ratio ne over 400 I bani I2 u-I1 yena ngubani? I1 ngu-28.5 basibala u-I2 and ujonge ke sofumana the same percentage, yabo, even though we are referring to the secondary side. Okay, so we just calculating I2. Okay, over 400 times 28.5. The secondary current yethu is 142.5 amps. Okay, now we can calculate ke ngokwe percentage resistance. 142.5 over secondary voltage siyayazi, then resistance referred to the secondary. Resistance referred to the secondary surely sibala ngale question of which is baphume no, they got resistance referred, equivalent resistance referred to the secondary. It's okay, it's equivalent resistance referred to the secondary is 0.082 over 400. Okay, then let us punch ke ngoku and see 142.5 of 0.082 over 400 over 400 ane singalibala times ngo-100 because sifuna in percentage, sifuna in percentage la value times times 100. Yabo sisaphuma nabani no 2.921%. Yabo it's still the same answer, but choosing to refer the primary winding to the secondary side, it's a longer calculation, yabo. Then bathi ke ngoku the next question iti calculate the percentage reactance of the transformer, of which is sizothi percentage reactance is equals to, let's use referring to the primary because bonilba why it is shorter, yabo. I1 x E1 over V1 times bani 100%. So izoba ngubani? Izoba ngu-28.5 times reactance referred to the primary, it's 11 over 2000 times 100, and ndifumane ntoni? Ndifumane u-15.675%. Then uthi calculate, express the impedance in percentage form. Impedance in percentage form sizothi percentage impedance is equals to percentage resistance plus J percentage reactance, and of which is a percentage of which is guys a percentage resistance ngubani percentage resistance esibalile ngu 2 2,921 ana plus J ibe i-percentage percentage reactance yona ngo sanayibala percentage reactance ku 15,675 ana, then that is in percentage form. We have expressed impedance in percentage form. So guys, that's it for this part of a transformer calculations. My students, please ngicela nigqibezele ke ngoku nenze u3 activity 3.1 wonke, please. Thank you.